Okay, today we are talking about 9.1 sequences and series. You see in this first example we have a list of numbers 7, 13, 19, 25, and 31. Can you see the pattern? To go from one number to the next, you add 6. And these numbers are in a certain order. If we switch some numbers around, it would still be a sequence, but it would have a different pattern. So the definition of a sequence, it is an ordered list of numbers. Each number in the sequence is called a term. So this would be the first term, the second term, the third term, and so on. By putting a dot, dot, dot at the end, these are called ellipses, we are being told that the pattern continues. If you could find the pattern, like in this case, add 6, it makes it easy to continue the sequence and find the next numbers. Now, I'll often use a variable, such as a, to label each term in the sequence. Since this is the first term, we'll make a subscript here of a 1. So this is A1, A2, A3, A4, and A5. These subscripts tells you which term the number is in the sequence. Now, subscript is actually a typing term, and it tells you that the number is written down below and it's smaller. The actual mathematical term for that number is the index. Okay, every sequence has two patterns that we're interested in. What we saw before of adding 6 is called the recursive pattern. So that is the pattern that repeats, or if you see this here, recurs to take you from one term to the next. So for this example, since we had to add 6 to go from one term to the next, that would be the recursive pattern. Now we will get into the way you actually write that later. For now, we could describe it by saying add 6 to the previous term to find each number in the sequence. Knowing this would allow you to find the 6th term, the 7th term, the 8th term, and so on. But if we wanted to find the 100th term, it's going to take a lot of work. So that takes us to the second pattern we want to look for, which is called the explicit pattern. Now this pattern will allow you, give you a formula where all you have to do is plug in a 1. It'll tell you that the first term is 7, or the second term is 13, the third term is 19, and so on. So the explicit pattern is a pattern that relates each term in the sequence with a subscript. Remember, the math term for that is the index. Sometimes the recursive pattern will be easier to find. Sometimes the explicit pattern will be easier to find. So for our example from before, to find the explicit pattern, it might help to rewrite it in a table. So the sequence was 7, 13, 19, 25, and 31. This was the first term, the second term, the third term, the fourth term, and the fifth term. When we talk about the indices, that subscript, we will always use the variable n, and that makes each of these a sub n. So when n is 1, this is a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Push pause and see if you could figure out the pattern or this formula that will take you from the top to the bottom. To get from the top to the bottom, you have to multiply the top number by 6 and then add 1. And this works for every single number that we have in the sequence. So we could write the explicit formula or explicit pattern as a sub n equals 6n plus 1. Finding sequences takes practice and takes a lot of exposure, and it's helpful to have a few tools in your tool chest. So we need to create these sequences, and it'll help us out later. So multiples of 2. 2, 4, 6, 8, and 10. Multiples of 3. 3, 6, 9, 12, and 15. Powers of 2. Now we could have the first term in the sequence be 2 to the 0 power, which is 1, or 2 to the first power, which is 2. We just need to make a choice. So let's start with 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. Powers of 3 would be 3, 9, 27, 81, 243. And our first perfect square is a 1, a 4, 9, 16, and 25. Now remember, these ellipses here means the pattern continues. And often what we do to finish this up is we find the explicit pattern for the sequence and write that here. This is the first term, the second term, the third term, the fourth term, the fifth term. So our pattern here is 2 times n. See if you could figure out the rest of these. Push pause, and then when you're finished, come back. Okay, here we have 3n. Powers of 2, so 2 to the n power. 3 to the n power, and n squared. In this first sequence here, since this is called the first term, the second term, the third term, the fourth term, and the fifth term, this is known as the nth term because 1, 2, 3, 4, 5, n is written like this. So each of these formulas can also be called the nth term of the sequence. And often our book won't ask for an explicit formula. Instead, it will say find the formula for the nth term of the sequence. And this is what it means. Okay, so we have two different types of patterns that we're looking for, the recursive and the explicit. So To describe a recursive pattern, two things are needed. Do you remember that first sequence we looked at? The recursive pattern was to add 6. But if that was all I told you, you would not be able to recreate this sequence. You would also need to know that the very first number was 7. So the two things you need to know to create a sequence recursively is the first term and the pattern. On the other hand, to describe an explicit pattern, only one thing is needed. Remember what we did here? We had our sequence and we figured out the pattern was 6n plus 1. So if I gave you this formula, you can recreate the sequence by plugging in 1, 2, 3, and so on, and you would know it. The only thing you need is the pattern, or you could think of it as the formula. To finish up, here are a few sequences. Why don't you take some time, look through these, look for patterns, and see if you could find the explicit formula for each one. Push pause. Okay, so here we go. It might help you as you do these to actually create a table. 1, 2, 3, 4, 5. And remember, you're looking for a formula that will take you from this number to this number. So this first one, 3n minus 2. Notice that to go from one term to the next, you always have to add 3. So that is the recursive pattern, and this is the explicit pattern. This one, each of these numbers is 1 less than a perfect square. 1, 4, 9, 16. N squared minus 1. When the numbers go back and forth, positive and negative, it is called an alternating sequence. Since it is fractions, don't think of it how to get from one fraction to the next. Instead, try and focus on moving from the top and the bottom. So the sequence on the top is n plus 1. On the bottom is n plus 2. Now, to get the negative, positive, we start with negative 1 and we raise it to the n power. Negative 1 to the first power is a negative. Negative 1 to the second power is a positive. Negative 1 to the third power is a negative. To the fourth power is a positive. So that allows you to switch back and forth, positive and negative. Anytime you have an alternating sequence, you can always use that to fix it. Now our last few here, n plus 1 over 2n minus 1, 1 over n squared, and this last one could be negative 1 to the n plus 1 or negative 1 to the n minus 1.